Hello there, it's KP the Math G. I decided to do a video on derivatives from a table. So given a function f and its derivative f prime, which by the way is continuous for all real numbers, which means that f and f prime are differentiable. Okay, that means they're f prime, which is continuous. That's what we're talking about. Differentiable. Actually, differentiable means continuous. Okay, I should have said differentiable. Anyway, find the following. Alright, we want to let g at x be 2x minus 5 and times f at x. Now, a lot of times when you see a problem, you will not see the time sign there, but it is understood to be there. Okay. We want to find g prime at 4. Now, this right here is the product rule. Remember what the product rule is. If you had say h at x being or something equal to a times b, then h prime is going to be equal to a times the derivative of b plus the derivative of a times b, like that. So that is how we do that. It's the product rule. Okay, so let me erase this and let's find out what g at x is, or g prime at x is. Alright, so g prime at x, let's put it down here. G prime at x is equal to, looks like my color is running out, so I'll get a different, well, almost the same color. Let's just rewrite the first one. So 2x minus 5, alright, there we go, times the derivative of f. We'll just say f prime. Yeah, I took a derivative. It's f prime at x. That's what it is. We don't have a particular function of f, so we just say f prime. Well, this is the function, okay, of f here. Alright, so plus now the derivative of this, which is just 2, right, times now just plain f at x. Okay, the first times the derivative of the second plus the derivative of the first times the second. Okay, and let's just figure this out now. We want to figure out what g prime at 4 is. Alright, so we're plugging 4 everywhere there is an x there. So 2 times 4 minus 5. F prime at 4. 2 times f at 4. Alright, now one way to remember how to do this table, if I wanted to say, for example, f at 5, that's just f at 5 is 1. Okay, equals 1, like that. If I wanted to do f prime at, say, 5, then f prime at 5 would be 2. Alright, like that. See how it works? Alright, so that's how that's going there. Alright, so let's just plug them in. Well, let's see. We don't have anything here. It's other than to say 2 times 4 is 8. 8 minus 5 is 3. So 3 times, now f prime at 4. So I'm looking at f prime. I'm looking for 4. F prime at 4 is 5. Alright, 2 times f at 4 happens to be negative 3. Alright, so 3 times 5 is 15. 2 times negative 3 is negative 6. 15 minus 6 is 9. And there it is. That's how you do that one. Do you see what's going on? You're just taking this is just immediately know this is a product rule right here when you see this. And then just follow the product rule. First times the derivative. That prime means I took the derivative of f. Okay? And then plus 2, or derivative of this, times f, like that. Alright, that takes care of that one. So I'm going to go ahead and erase that. Just kind of see what's going on here. And you got it. Alright, here we go. Let's do another one. Alright. Now, let's try this one. Let's put our symbol up here. Use a different color. Things get boring when we use the same colors all the time. What color can we use? Let's try this one over here. Haven't tried these colors yet. I've got all sorts of markers everywhere. I haven't tried this. Let's try it. Well, let's see what we got here first of all. Alright. Alright, so now let's let. Oh, look at that. Pink. Okay. Let h at x. Well, we're going to let h at x be something. Now this is f at x. Halloween's already gone, but to some folks here that looks scary. Don't worry, we do have KP the Math G right here, and we take care of everything, and he takes care of everything that is scary here. I want you to look at it this way. Let's say you had h at x is equal to sine of 4x. Okay. Then this is the f part right here. That's the outside right here. This is the f. The f at x would be right there. Alright? Alright, and this is what we're talking about here. H is f. F would be sine. So all you're doing is you're saying h prime at x would be the derivative of sine, which is cosine. Oh, the chain rule, KP, that's right. Remember, f at x doesn't change, but then you have to take the derivative of f, which is 4. So in this case, it would be 4 cosine of 4x. Okay, like that. Alright? So that's it. That is called the chain rule. Alright? So I just had to throw out a little extra problem there. Hey, that's pretty cool. I like this now. It's not so scary. Alright. Now, h prime at x. Alright, now that's f prime. Took that first derivative, didn't I? Work on the outside, leave the inside alone, and then times, take the derivative of the inside. Well, the only thing we can do is say f prime at x. So the derivative of the outside times, well, I'll do nothing inside here, times the derivative of what's inside. This is the chain rule. That's what you see. If you see this, just know that you're applying the chain rule. Well, let's see. We need to find. Okay. So we just let that. So what we were looking for is we need to find. I need to put it over here. Find. I got a little ahead of myself then. H prime at 5. Okay, so I want h prime at 5. H prime at 5. So this is f prime, f at 5. I know what f at 5 is, don't you? times f prime at 5. Looks simple enough to me. Alright, so let's see what we can do here. This is f prime. Now f at 5, f at 5 is 1. So f prime at 1 times f prime at 5. Okay. F at 5 is 1. So f prime at 1, f prime at 1 is 4 times f prime at 5 is 2. I do believe I have that correct. So f prime at 1 is not 4. F prime at 1 is 3. It's an easy mistake to make. I did f at 1 times f prime at 5. F prime at 1. F prime at 1 is 3. There we go. Easy mistake to make. Instead of getting 8, we should be getting 6. And I knew when I saw that, I said, that doesn't look right. So there we go. Okay. So f at 5. F at 5 is 1. F prime at 1 then. F prime at 1 is 3. F prime at 5 is 2, isn't it? 3 times 2 is 6. The chain rule. Okay, nice. I really like these. I want to do one more. I made it up myself. I think I made up this table here too, by the way. Alright, let's see here. Okay, now let's do one more. Let's do this one. Let's given. We're going to do a couple of givens here. Given that we let c at x for x minus 1. Simple enough. And I want a at x to be equal to c at x over f at x. And I want to find a prime at 2. That's what I want to find. I want to find a prime at 2. Make that a little better. Okay, a prime at 2. What do you say we find a prime at x first, okay? Well, here we go. Let's see. Let's get another color out. Yeah, how about this one? Alright, so a prime at x. What do you recognize this to be? It's a quotient. So we're going to have to apply the quotient rule. Alright, remember there was, we said something about a low d high. Let's do it L and alright, so it would be, whoops, I think the derivative would be low d high minus high d low over low squared. Alright, low, high, high, low, low squared. Okay. Alright, well, let's do it. Low, alpha at x. I always like to look at it this way. You bring the alpha at x up. Don't do any more to it. You've already made one move. Alright, low times c prime at x. That's the derivative of the high. Alright, minus high d low all over low squared. Good enough? Well, let's see now. Wait a minute now. I got alpha at x. Alright, so this is equal to alpha at x now. I want to take c prime at x. What's the derivative? What is, if c at x is equal to 4x minus 1, what is c prime at x equal to? It's just 4, isn't it? Alright, remember that? The derivative of 4x is just 4 and the derivative of constant is 0, so just 4. Alright, so this portion right here is just 4. Alright, c at x, which is, by the way, 4x minus 1. I like to do that. I like to really block that off. Times f prime at x. Alright, all over low squared. Alright, now what we need to do, let's erase this now that we've done the derivative. Remember, these were one of the first things we did. Remember we did the power rule first, and then the product rule, and then we did the quotient rule, and then we did the chain rule, didn't we? Same thing here, except we're just using a table. Now we need to find a prime at 2. So this is a prime at x. Alright, so now a prime at 2, let's just go ahead and put it, this equals, a prime at 2 equals. Alright, 4 times, okay, so we're going to put 2 in place of this, so alpha at 2 times 4. Well, I don't know if I'm going to have room here. Minus, I might not have enough room. Let's try it. Minus, okay, 4 times 2 minus 1, okay, times f prime at 2. F prime at 2. Wow, we just squeezed it in, didn't we? Alright, all over f at 2 squared. And that's what we do now. Now we can use our table, can't we? Alpha at 2, let's see, I'm following alpha at x, so alpha at 2 is 2. So this is equal to 2 times 4. Alright, minus sign. 4 times 2 is 8. 8 minus 1 is 7. Times f prime at 2. F prime at 2 is negative 2. Double checking. F prime at 2 is negative 2. Alright, we got it. Now f at 2 squared. So now f at 2 is 2, and then 2, f at 2 is 2, so we're just squaring 2, which is really 4. Okay, so I think we can get it pretty quickly. This is 8 minus, all right, 7 times negative 2 is negative 14 over 4, isn't it? Which is 8 plus 14, all right, so 8 plus 14 over 4, 22 over 4, 11 over 2, and there it is. Wow, you can do this. You think about what you're doing, you can do this. You know what c at x is. You know that a at x is c at x over f at x. Then just simply do the quotient rule. This is a quotient. Low d high, there's my d high, minus high d low over low squared. And then a prime at 2, start plugging those in there. Okay, and there it is. Alright, so we did 3 problems. We did one by the product rule, one by the, what was it, chain rule, didn't we? And then the third one by the quotient rule. So kind of a review of how to do all those, but here again, this time we had a table here. So once again, this is KP the Math G, wishing you a great day. Do not forget to hit the subscribe button. Okay. Please make comments after I process this video, which will take me just a few minutes to do that. You can come back in, or you when you come back to see this, or when you see this, you can make comments along the way, and I'll be glad to take comments, good or bad. Just if you make a bad comment, please say something that will be helpful to me, something that will help me understand this better. If I'm doing well, then comment on that. But if I'm doing something I could do a little better, then comment on that too. I appreciate you listening here, tuning in to this video. Again, this is KP the Math G signing off. Have a really, really good day.